Now we will have a presentation with Guichet, the Pharo module system. Guys,
It's okay. So, hi. Hello. So, can you raise your hand if you don't know me? Okay. So I present myself. Cool. So I'm Guille. So it's written like this. I'm from Argentina. So it is pronounced Guille. Like I don't know. I wrote it here in International Phonetics Alphabet. This is kind of pronunciation in French, something like that could be in English, I don't know, Guichet. So I am a researcher in INRIA in Lille, in the north of France. I work, so I contribute to Pharo regularly since 2010 and do many different things. So now I like compilers, testing, test generation, and many other things. So at some point I was learning Japanese on my own, reading a lot of chess chess books lately. I don't know. So, yes, and I have this bad thing. I need to move, but I don't have to move, so it will be very difficult for me. So I know, but no. Yeah. Okay, I will try, but in any case, I will move my hands. So okay. So what is this presentation about? I don't know if you were for a couple of years in the Pharo mailing list or you are following the issue tracker, you have seen things like this. So this is a mail, we don't see it very well, but this is a screenshot for a mail James sent like 16 years ago. Yes, when Herman Leiva was doing a Google Summer of Code about having namespaces in Pharo. I remember, it was we were in Concepción del Uruguay. Yes. Now this was 16 years ago. This is last 3 years ago. Jean Privat was asking, okay, can we have namespaces? So this is something that everybody asks from time to time. So I was looking also for the mails from Torsten. Torsten had this thing that he was sending a message every 2 years. We want namespaces. Which is okay. So and this is actually that is tickling our head since a long time. So with Luke, I don't know if Luke is here. No, probably. Yeah, Luke is there. So with Luke and Steph, it's something that we were thinking about for a long time. So it's years that we think, okay, what should we do? How do we do it? So can we have namespaces? So in this presentation, I will say no. Yes. So no, we cannot have namespaces because the problem is that namespaces are not enough. Yes, you want namespaces for many different reasons, but actually I will try to convince you today that we would like something more than just namespaces. Because if namespaces are there just to not put the prefixes on class names, well, the added value of a lot of infrastructure, maybe it's not so much, but maybe we can do more. Yes. So. Let me first let's think a bit about what do we mean by namespaces. So we don't see it here. So this is a Pharo screenshot and it stops here. So you don't see it, but okay. I will have problems with the presentation. You will see. So inside Pharo we have, for example, right now we have packages. But let's say that we have and right now, for example, if you want to have classes that are named similarly, you have to prefix those classes. Like, for example, you have object in kernel, and it wouldn't be very strange to have OC object in Opal for Opal compiler, or test object in SUnit. Okay, it doesn't exist in reality, but I remember having Java projects where people create an object class in a different namespace, and yeah, so then you have two objects in your system, and you need to understand how the imports are actually playing. So okay. Now, if we had namespaces, one thing that we could have is this. Okay, I have object in kernel, I have object in Opal, I have object in SUnit, and that's perfect. Now, the problem is that as soon as I want to use the object from Opal inside SUnit, rules can get complicated. Yeah, so I need to understand, I need to prefix something, or I need to import with a different name, or I need to have aliases, I don't know. Yes, so, okay, but this is one of the main reasons I think that why people ask for namespaces. Now, when I think about namespaces, I am thinking about other kind of issues or other kind of features I would like. For example, porting old code. let's say that I have, again, Pharo 14. I have kernel, Opal, the compiler, and I have SUnit. I have different frameworks, libraries here. And I would like to take some old package from Quicksource. How many people here know Quicksource? Barely a third. Okay, half. And I want to take something from here and put it here in Pharo 14. Chances are it will not work, right? Because of many different reasons. Maybe the code will not compile. Yeah. So, for example, if assignments are written in the old style assignment where we were using the little arrows or the underscore, that will not work. Or maybe these have dependencies that are not available here in this environment. So now it doesn't matter. I would like to be able to port all code in here. And how can actually, I don't know, namespaces or modules or something like that help me with this task, right? Also, in 2 days, I have another presentation, right? So that is named Modularity by Construction. That is myself. Yes, writing this presentation. And when I was preparing this presentation, I was thinking about the different things like the bootstrap, doing refactorings in the code. We will talk about that on Thursday. But migrating code, thinking about compatibility and how can we keep compatibility and so on. And then something that happens a lot of the time for us is that, okay, I have something in Pharo 13 and I want to run it in Pharo 14. So maybe not from Quicksource, but I want to have the compiler from Pharo 13 running on Pharo 14, and I don't want this. So I want these two compilers running side by side and not having conflicts between them, right? Because chances are 80 or 90% of the classes in Opal version 14 will be the same names that the Opal version 13. So, okay, that means that we need more than just prefixing or unprefixing, yes? And I would like this to be able to be feasible. So how can we help people to port packages and to share code and to have different versions of the package side by side in Pharo? Now, what is our goal? Yes, so when I was thinking about modules and namespaces, I'm thinking not only about namespaces. I'm talking about also how to help people to ease migration of code from one version to another, maybe different versions of the system side by side. Maybe you want to debug some library and you want to have the version with the bug and the version without the bug side by side to understand what is happening, what introduces the issue. Yes, I would like to have tools that simplify compatibility. Like, I don't know, can we virtualize Pharo 10 inside Pharo 14, and what are the minimal things that we can do with this? And we want to keep as backwards compatible as much as possible to not break what you are doing. Yeah. So, okay, this is what I want. Can we do it? That's a question. So yes. Well, here we see the quality is very bad. So yeah, take my money. Give that to me. Okay. So we started to make a module system. Right. The story goes like that. And then what is the principle of the module system? Pretty easy. So right now we have these Smalltalk globals, which is a single namespace. All classes and all global objects share the same namespace. They live in the same dictionary, and they can see each other, right? This is how it works right now. You do Smalltalk globals, and you can fetch anything that is there. You install some code, and all the things that you are installing go in there, so they are visible by everything that was installed before and everything that will be installed later. And the main idea of the implementation of this module system is, okay, let's cut this global namespace into small namespaces. Yeah, so we have, for example, one for the kernel, where the kernel can see the things in the kernel, but it cannot see things outside. And then we have morphics, for example. We have morph, model, and so on. And we have some other, okay, I missed the refactoring of the presentation. So, and we have other packages that are splits like that. Yes? So the key idea is, we would like to have a module system, and inside this module system we have a namespace. We will implement namespaces, and these small namespaces are compiled separately, and they will be linked between them. Yeah, because this guy is probably the superclass of many other classes. So there is a link between things here and things there. So we need a linkage mechanism. Yeah. So okay. Oh, it's already 9 minutes. So now this is me writing the module system, yes, for all these scenarios. And I started writing this, and then we need to be able to express links, we need to be able to express imports, we need this separate compilation, we need a module registry to register modules and know what is available in the system and so on. And then what happens, and this is what happened, I don't know, early this year, maybe late last year, is that we found a big obstacle, which are the extension methods. Yes? Now the rest of this presentation is just a big rant of why extension methods are bad for modularity. And I will try to explain you that, and I will try to explain you what are the things that we are trying to do to minimize that pain, so we can overcome this obstacle and have a module system in the close future, right? So what is the issue with extension methods? Is that extension methods break modularity. So by extension, they break the module system. Let me give you some examples, but first, for those that do not know what extension methods are, the idea is that, let's imagine here we have a package. In this package we have classes, so object, string, character, and so on. And then I can, in my own package, for example, this is Petit Parser, this is a library to write parser combinators. And what Lucas Rangley did at the time, when he wrote Petit Parser, was he added methods into the character class, into the string class, and in the symbol class, and so on. In each of these, he introduced an asparser method. Yes, of course, you don't want the asparser method to be integrated into the core. You want them to be part of your library. So we package these methods within Petit Parser, and then we can commit all these together. Yes, so what extensions methods allow us is to add new methods to existing classes that we don't own. Yes, so Petit Parser is not owning the object class, but we can still add methods there, and we can interact with the system in this way. So we extend by adding new behavior. Now, this is actually a super nice mechanism, and it's pretty cool, and it's used for many different things. It's used, for example, for having kind of syntax sugar. So instead of writing every time, pp string parser on string, you can just write string as parser. And actually, this will just do the same. This as parser method will do this inside. But writing this is probably shorter, it's cheaper, it's sometimes more understandable. So people, a lot of time, prefer this kind of notation. Sometimes we are going to use it to adapt interfaces. So if you read the Gango 4 book on design patterns, you will see the adapter pattern. Well, if you have extension methods, you don't need to wrap an object with another object that provides a polymorphic API, blah, blah, blah. You can just add the new API as a method in the existing class. So we can express design patterns in a different way because we have a language that helps us with that. And for example, one of the nice things about this is that we can exploit polymorphism between extensions. So, like, all parsers understand as parser, returning themselves, and then string as parser returns a parser, a string parser. But like that, a parser is polymorphic to a string in some way, and it kind of simplifies a lot of software construction. And you cannot see it very well, and it's on purpose. A lot of people use it for monkey patching. Yeah. So what is monkey patching? Is you are going. I have an example later, but the idea is that you don't own the class. You add an extension method because there was a missing feature, and instead of doing the pull request to the nice guys that maintain the library, no, you go and patch it yourself, and then eventually, and you hope that the class that you're extending doesn't change, that you are not breaking anything, and so on. So I will show an example later about that. So we have these nice extension methods, and the main idea, again, of extension methods is that they extend classes that belong to other packages, so packages that you don't own. Another way to read this thing, since you can extend any class and put any method in any place, is that this is a mechanism that you can use to maybe break a class that you don't own. Yes, so they could be used in an evil way. So how can we control them? You will see the next slide many times during this week. What is the vision that I would like to share with my 3 presentations of this week is, you don't break my toys, I don't break yours. Yes, something that you explain to kids. So if with an extension method I can break somebody else's code, this is kind of it's creepy. Yes, so you do your library, I do mine. Maybe we can talk together. How can we have an interface to communicate, right? But if I go and I can override the method that you have to change your behavior, I can break you. So you don't do that. I don't do that to you. You don't do that to me. That's a nice contract. So now let's go concretely why global extension methods, which is what we have, break the module system, and in particularly they prevent multi-versioning. Yes, I talked to you about this idea. I want to have this 2 different versions of a library inside Pharo. Yeah, inside different modules. So let's say here, for example, that I have the module kernel with the class object, and then I have 2 different packages, modules. We can call them whatever you want, different versions, and they extend this class here. Maybe they extend it with the same method with the same name, because of course they are 2 different versions of SUnit. Now who wins? Yeah? Yes, who wins? The latest. Today in the current implementation, it's the latest who wins. That's right. So you install, maybe you install this one, and then when you install this one, the extension method installed by this guy will override the method that is installed by the other one. Of course, if you do that, you are going to, one is breaking the other one. Yeah, because chances are that the implementations will differ. Yes, I am kind of convinced that this is not the correct behavior. So, what is a better solution? And this is what we are exploring right now: scoping. What does it mean? Is that actually it's not that one of them will win; both will win in a different context. Yeah, so one will win in one context and the other one will win in another context. So that means that the methods that this guy is introducing will be seen in some context and not in others, and vice versa. Yes, so both win, and we all win. So we are working then in a new extension model. It's a bit different from the extension model. So the extensions, we are trying to make them work almost the same as they are working right now, with a key slight little differences you are going to see later. So, but the idea is we have this extension, scoped extension models, where extensions are scoped. So we are controlling the visibility of extensions. And so you can still extend whatever you want, but it's not globally visible. It's not that I extend Steph and then anybody can talk to my extension to Steph. Only certain people that have the right to do it can talk to Steph through my extension. Yes? And how do we define those rules? By imports. So if you import my extension, then you can use that extension, and that's okay. But so I will say this will be probably a new thing. Yes, this is the most complicated thing here, because it will probably, we need to be able to declare these imports. But you have to think that every time that you have a class and the class has a superclass, you are importing the superclass. So the same way that you import a superclass to inherit from it, you should be able to import extensions to use them. So, I will not go into the details of how it works, because it's a bit of a mess sometimes. But it's important to understand what it will do. So, let's say we have in this example the object class in kernel, and then we have 2 different packages, modules, that extend this class with a method that is called foo. Yes? And here we have foo that returns 42, and here we have foo that returns 17. Now, if I send the message foo inside the package here, inside this module, this will return 42. Because since this guy is defining the extension, then this guy can see the extension. So that's okay. I define the extension, I can see my own extensions. So that's pretty simple. And actually no imports are needed here. The same thing on the right. If I define foo that returns 17, I can send a message foo and I see the 17. And then if I have another module that imports this extension, if this guy sends the message foo, it will see the 42. It will not see the 17, right? And if we have a 4th guy that doesn't import anybody, then if he sends a message foo, he will just have it does not understand. So these are the rules. Does not understand. Yes. So now the question is, does this model fly? Yes. So I want to, like a baby bird. Okay, go, fly. So we started looking at how extensions work in Pharo. Yes. So for example, a sneak peek in Pharo 14. I took an image the other day, and I ran a couple of scripts. So we have almost 5,000 extension methods, 3,200 extension selectors. That means that many of those methods share the same selector. Yes. Now, overview, almost half of these methods can be easily scoped. We can express easily these methods with the mechanism that I explained you. Yes, and some of them it's more tricky to see if this is easy or not. It's just because we don't. It's a dynamically typed language. It's difficult to analyze statically. So, but half of these we can automate and do a script that will migrate from the old version to the new version, and it will work. Why? Most of the extensions are local extensions. So 1/3 are extension. I am defining the extension, and I am the only user of the extension. So that means that this actually is pretty simple to do. Yeah. So a package defines an extension, uses the extension, and then this guy is happy. Cool. Now the second set of easy extensions to migrate is that most of the extensions are. So I call them monomorphic. Doesn't matter. There is a single implementation for them. So that means that there's only one implementer of that selector. That means that there's no polymorphism. That means that if you import the extension, that will automatically work, and there will be no issue. Yes. So this is a third. The other one is a third. They overlap, and if you join them together, the method of this third and the other third, that the local extensions, they make out around the half of the extensions, and those are the really simple ones. Now, there are a lot of other good extensions users. Yes, so not everybody does the monkey patching stuff. Yes, so for example here, this is the case of where the monomorphic extension, for example. So here I have a module that with object, then I have an extension on this guy, and if I import, I can see it, and that's okay. So most of the people do this kind of pattern, and as soon as you follow this normal pattern, that is okay. Even it works automatically with polymorphism, and we did a lot of work to not having to declare a lot of stuff. So it's pretty much automatic. So right now, for example, if you have object and string, and you have an extension here that extends object and an extension here that extends string, and you import both of them within this context, both will be polymorphic automatically. So, and that will work. Now, what is the ugly case? The ugly case, the bad citizen, is the monkey patcher. So the monkey patcher is this one. So you have in your kernel, you have object and string. Somebody is extending string, and somebody is extending object, and then this guy is importing only the string extension. Now, should he be able, or she, should this module be able to see this extension here? Well, in my model, in this model, it shouldn't. But there's a lot of code in Pharo, since this guy is right now global, that exploits the fact that this is global, and actually this works right now in Pharo. So this is the potential code that could be broken, that will need some massage. So how do we identify these border cases? A single question is that is very important. Do you own the call site, the person? So the place where we do the message send. So here, who owns this call site? The call site is owned here. The guy extending does not own the call site. So this guy doesn't have any influence of how this guy will work. Yes. So I know I have to stop soon. So yes. So if you own the call site, you just import the extension from the place where you're doing the message send, and then everything is transparent. If you don't, probably you're patching code. Yeah. And these cases will require probably some slight redesign, some rewriting we need to see. So, but the main idea, again, don't break my toys. I will not break yours. So I think it's at least we can discuss if this is the right semantics or not, but it's some sensible semantics. So what's done and what's next? I'm reaching the end of the presentation. Right now we have a module system that has separate compilation. It works pretty well. We tried also to not have explicit imports because they were a mess. So we are using a path-based system. So you have a path, and the imports are going to be taken from the path, like the class path in Java, something like that. Now we have a model of scope extensions using a coloring system. I can explain them to you later if you want, because the coloring system is complicated. It's just colors, but now we are missing tooling. So we will need tooling to cope with this stuff. So to inspect modules, understand, link them, and so on. Now this is, as soon as you cut the system in many small namespaces, you are going to break reflective access to the namespace. So if somebody is doing Smalltalk globals, well, Smalltalk globals doesn't exist anymore. Sorry. So what do I do? Well, that code is probably going to break. Do we emulate it, or I don't know? Those are decisions to be taken. And there are some optimizations that are still needed in the scope extension model. So just to finish, this is my last slide. So what do we want? What do I want? I want modules that are more than namespaces. I want them to have support for compatibility layers, multi-versioning, and namespaces. I want also scope extensions to control. So extensions are nice, but we want to control them a bit. And we want this thing to be as backward as possible and transparent as possible, even if it's difficult. And of course, I am presenting this, but I am not the only one working on this. So Luke and Steph, we were working on this a lot. And Nathan also, he's participating. He's an intern that is in Lille that has been working on this for the last couple of months. So thanks to all of them too. Thank you.
Thank you very much, Guille.